Okay, I'm recording homework for section 4.1. So question number 1, complete each statement. An event with a probability of 0 is, let's see what we have here. Impossible, certain, more likely to happen, less likely to happen. So less likely to happen, it's going to be less than 50%. More likely to happen, it's going to be more than 50%. Certain is going to be 100%. Impossible is 0%. So our answer is impossible. An event of probability of 1, take a guess. Of course, it's going to be certain. Okay, next one. Which of these values cannot represent probability of an event happening? 56%, that's normal. Maximum probability is 100%, as we know. So 56%, 7 over 8, 0.33, it also can represent probability. 1.2 cannot represent probability because portion-wise, 100% is 1. Right? So, let me see. Portion-wise is 100%. Portion-wise is 1. So if we have 1.2, that's going to be 120%. That's above 100%. Standard is 100%. I'm not saying 120% cannot exist, but the measurement goes from 1 to 100. So 120, it's going to be above, let me put here, plus 20%. Okay? So, this is 1.2 cannot be cannot represent the probability of an happening event. Okay, we have all good. Moving to question number 3. So which of the following events has a probability of 1? So let's figure it out. First one, landing on a blue or red space on a spinner with one blue and one red space. Okay, so if you are the spinner has blue and red, then it's going to be either blue or red, correct? So it is going to be probability of 1. So there are two colors, and what's the probability that two colors will hit? Okay. Next, we have drawing a peanut from a bag of trail mix with 4 types of nuts. Well, it's not going to happen because 100%, because you have 4 types and you are pulling only one type. 1 out of 4 it will be. Okay. Next, choosing a red marble from a bag containing red and green. Well, its probability here is 0. There is no red marble. No, here it is. Yeah, red and green. So if you are pulling only red, then probability cannot be 1, correct? Because there is green also. Next one, getting a heads or tails when flipping a coin. Well, coin has only head or tail, so this is going to be another 100% chance. So it's going to be head or tail because totally they have only head or tail. And last one, drawing a red card from a stack of 20 red cards. If you have total all 20 red, then it's going to be 100% chance that you're going to pull red one, right? Let's submit. Okay, we are doing good. Moving to question number 4. A sock drawer contains 5 different colors of sock. It has 20 white, 10 black, 10 gray, 6 red, and 4 purple. If you reach into the drawer and choose sock randomly. What is the probability you will get a black sock? So we are interested in black sock. We have total 10 black sock. Now this 10 we need to divide by total. How much we have? 20 whites, 10 blacks, it's 30. 10 gray is the 40, and then 6 red, 4 purple is 50. 20, 30, 40, and 50 total. So 10 is subject of our interest, black ones, and 10 over 50. So we are going to get 1 over 5. 1 over 5. 10 over 50 is 1/5, right? Bingo. Next question, moving to question number 5. Your teacher is giving out fruit for lunch. A paper bag contains 4 apples, 6 pears, and 8 oranges. So what's the probability you pick orange at random? Total, how much we have? 4 plus 6 plus 8, 18. So 18 is total, and oranges are 8. 8 over 18, let me write down here. 8 over 18, we can reduce by how much? By 2, it's going to be 9 by, it's going to be 4, and it's going to be 9 here. I was looking at 18. So 4 over 9 is going to be our probability. Let me see. Oh, here it is given. Very good. Next, what is the complement to this event? Okay, the complement is going to be total, we said 18, and orange is 8. So 18 minus 8, it's going to be 10, which is apple and pears. Complement is going to be 10. They want pulling, they want this type of answer. So pulling apple or pear. A pear, either apple or pear. There we go. This one. Because complement, it's what's the case when orange is going to be missing. So will be left apples or pears. Next. What's the probability of complement? Actually, I was doing probability. So complement, if we won't count, total we have 18, and without 18 we have apple and pear is 10. Let me write down. So apple 4 and pear 6 over 18. So we get 10 over 18, right? This is total, and this is subject of our interest, complement. 18, or you can do 18 minus 8, right? Orange, that will give you complement. Well, divided by 2 is 5, by 2 is 9, 5 over 9. There we go. And then which fruit is more likely to be chosen? So which one we have the most? And that one will be the most likely. Orange is 8. It's the most. So it's going to be orange. All right. Let's check. Bingo, all of them are correct. Moving to question number 6. All right, what do we have here? A fair 6-sided die is rolled. Find the probability of getting less than 4. Okay, let's do it. We need less than 4. It's going to be what? 1, 2, and 3. Total, how many we have? 6, right? 6-sided, correct? So we take 3, because we have 3 elements total, right? 3 cases. 3 over total 6, it's going to be 0.5. Okay, let's enter it. 0.5. Okay, this is supposed to be, let me see. Okay, so 0.5. All right, let's submit. Bingo, correct. Moving to 7. Where from is this? Here. Okay. You roll a fair 6-sided die twice. Now we are elevating the problem. It's more advanced. Find the probability of rolling a 4 the first time. So rolling a 4 first time, it's going to be, how many 4s are there? 1. Among how many, how you call it, holes or marks? 6 total, right? Maximum from 1 to 6. So there are 6 of them, and how many of 4 you have? 1. So it's going to be 1 out of 6. That's a probability of 4, right? Let's move to next one. First time, and number greater than 2 the second time. Greater than 2 the second time. So it's going to be greater than 2. It's going to be 3, 4, 5, 6. 4 of them out of 6. Right? Okay. How much it's going to be? Since it says probability of rolling, how much was that? A 5, I think, right? A 4. Okay, first time, and keyword is and, because and is converted into multiplication and or converted into addition. Let me rewrite it again. I believe in previous homework I did that, but let me write down. When you read and about events, this event and that event, it's converted into multiplication. But if you see this event or that event, it's converted into addition. Since it says and, then these two probabilities, we are going to multiply 1 over 6 times 4 over 6, and we are getting 4 over 36 or 1 over 9, right? So 1 divided by 9, we are getting 0.11111 and so on. Bunch of ones. Let's write down here. So 0.1111111, endless ones. Okay. Checking. Good job. All right, moving to question number 8. The number of M&Ms of each color that were found in a case with 1,874 M&Ms is given in the table below. Okay, so total is 1,874. So find the probability that randomly selected M&M will be in the category yellow. How much is we have yellow? 200. So we are taking 200 and we divide by 1874 because it's total, right? Let me see. 200 divided by 1874, it makes 0.106, or maybe we can just write down in the form of fraction, maybe. Okay, let me see. If I reduce by 2, oops. If I reduce by 2, this is going to be 100 by 2, 18. It's going to be 9. 7 by 2 is 3, and 7. So we get 100 over 937. And that's pretty much it. Okay, 100 over 937. Let's write down. So I'm going to use this format. So 100 over, how much was it? 397, I said? 937, okay. 937. And this one, yeah, it's in fraction, and this one till 3 decimals. Okay, so 100 divided by 937, and I'm getting 0.3 decimal. It's going to be 0.107. Checking. Good job. Very good. Moving to question number 9. So what do we have? Question number 9. So given some blood type information, what is the probability that randomly chosen American does not have type O blood? Randomly chosen American does not have type O. So if O, assuming all together is 1, because probabilities is all information in there, that's been 100%, that means 1. So if does not have type O, it's easy to take 1 and do minus type O, which is 0.57, I believe, right? Type O, 0.57, or you can take and add 0.19, 0.02, 0.22. That will be your complement. Yeah, that will be your complement. So since what's the probability that randomly chosen American does not have type O, we take 1 minus 0.57, that's going to be 3, 4, and here is, hold on, 4, and here is going to be 0, 0.43. So, okay, I guess the whole piece is not 1. Let's double check. So what do we have? 0.57 total, let's see. I would assume it should be 100%, but let's check it. 0.57 plus 0.19 plus 0.02 plus 0.22, 1. Well, that is correct. So the all this probability you add, you get 100%. So one more time, let's read. What is the probability that a randomly chosen American does not have type O blood? Which means 1 minus 0.57, right? 0.43, round till the nearest 0.01. Well, I'm curious, let's see. Oh, duh, I have in decimal notation, they want percentage. Who can stand probability? Well, probability you put in decimal also. All right, we put 43 if that's what they want. I was wondering. Question number 10. A ball is drawn randomly from a jar that contains 5 red balls, 4 white ones, 4 yellow. Find the probability that red ball is drawn. So we have total how many? 5 plus 4 plus 4, 13. So it's going to be, if we need the probability for red ones, it's going to be red is 5, total is 13. 5 out of 13. And that is equal, let's find out, 5 divided by 13 is equal 0.38, which means 0.4. Okay. I'm guessing they want to leave all decimals, so let me clean and we do it over and leave the decimals. Since it doesn't say to round, and we leave the whole thing together. Okay, red balls, 5 over 13. Let's divide. Red is 5, total 13. 5 plus 4 plus 4. Red plus white, right? So 5 divided by 13. And we are getting 0.384615338. To be honest with you, in statistics, usually they leave the whole 9 yards of decimal notations together. They write down because it can make important difference. But it's since it's education purpose, so sometimes they ask to round, sometimes they don't. So we just follow what they want. White ball, we have total 13. White ball, we have 4. And looks like yellow also going to be the same. So 4 divided by 13. And we are getting here 0.307 69231. Okay, now a red or white ball is drawn, so we need to add because we have or. So 0.30 and blah blah blah. I'm adding the red one, which is going to be 0.38461,538. And we are getting 0.69230769. Okay, yeah, that was the reason. Okay, rounding. And we solved the last question also. A jar contained 5 red marbles numbered 1 through 5 and 6 the blue marbles marked numbered 1 through 6. A marble is drawn random from the jar. Find the probability that marble is blue or add numbers. Okay, is blue, so 5 red numbers and 6. Total is going to be 11, right? Total is going to be 11. So the blue, how many blue we have? 6. So it's going to be 6 over 11, blue one. This is blue plus red, right? And this is total blue ones we have. Yeah. 6 over 11. And or add numbers numbered. Well, I'm not quite sure. Add numbers only for blue or I guess over blue. So add numbers is going to be since numbered 1 through 6, so it's going to be 1, 3 and 5, right? So blue ones add number 1, 2, 3, 4, 5, 6. So add ones, it's going to be this, 3 of them, right? So plus 3 over 11 total, correct? So we are getting 9 over 11 because we are adding. So 9 over 11 is going to be, let me clean this, 0.81818182, the whole 9 yard. We are going to keep it. So this is gonna be 0.81818182. Let's check. Bingo. That's it. I'm done. This is first one. Shortly will come the second one.